This is a demonstration video looking at some of the chemical characteristics of elemental bromine and some of the chemical reactions between aluminium and bromine and iron and bromine. Bromine is positioned as a halogen in the periodic table, and the natural state of bromine at normal temperature and pressure is a liquid. When we open a bottle of bromine, you can see a reddish brown vapor emerging from the neck of the bottle. This is because bromine has a relatively high vapor pressure. And when we pour bromine into a flask, you can see a reddish brown liquid at the bottom of the flask, and above this liquid is a reddish brown vapor, which is elemental bromine. The first reaction we're going to show is bromine reacting with aluminium. The aluminium is in the form of aluminium foil. So we've dropped a small piece of aluminium foil into the flask containing bromine. And after a couple of seconds, you can see a reaction starts. And this reaction is aluminium reacting with bromine, forming aluminium bromide. We can see a white, sort of gaseous vapor being generated, which is exiting the top of the flask. This is a form of aluminium bromide. It is important to note that elemental bromine is highly toxic, and all these experiments were conducted with great care in a working fume cupboard, as breathing in bromine vapors is highly harmful and toxic. So let's see the same reaction again, aluminium and bromine, but this time with a slightly larger piece of aluminium. So in the next demonstration, we're going to look at the reaction between bromine and iron. So using a similar setup as before, we pour some liquid bromine into a flask. And the iron is in the form of iron wool. The iron wool has two metal rods attached to it. With the iron wool submerged in the liquid bromine, no obvious chemical reaction takes place at room temperature. This is because there is an activation energy. To help overcome this activation energy, we've connected up an electrical power supply to the metal rods which are attached to the iron wool, and after passing a couple of amps through the iron wool, we've now heated the iron wool and given the system enough energy such that the bromine reacts with the iron in quite a spectacular manner. It may be of interest, but as soon as we saw the reaction occurring between bromine and iron, the heating power across the iron wool was turned off. As the reaction is exothermic, heat is generated, thereby helping to propagate the reaction. On removing the metal rods, there was, however, some unreacted iron wool present. Thanks for watching.